We kind of ran out of time to go over that problem yesterday, so that's okay for it though. Alright, so number 4, tell how many significant figures, oops, I'm in the wrong section. Sorry, I'm on the wrong page. Number 4, state the meaning value of the following SI prefixes. Alright, Cinti, we'll just go these back and forth. Alright, Chris, what you got
Are
for
you
the first
going in
one?
order?
Yes, please.
Okay, 100.
Good job. So 100, or there's 100 centimeters in a meter stick. That works. All right, Millie. Chris, not Chris, because I just called him Chris. Ethan.
1,000.
Good job. 1,000. Micro. 1 million. Mega.
1 million.
1 million. Kilo. 1,000. And a nano.
1 billion.
Good job. All right, you are also supposed to do application number 1 as well for it. Now, we kind of ran out of time for this one. All right, what equation did you use, Chris?
I used the one that's up there, P equals M over V. But what I did,
I did that.
All right, so this is rho. Technically, I know it looks like P, but it's the Greek letter, but it looks almost exactly like P. So yeah, so rho equals M over V. What does M mean? Remember?
Isn't it like meter, or no, mass over
Mass
volume?
over volume. Good job. So the problem to go over it says find the density of mercury if it is 205 milliliters and has a mass of 2,790 grams. Round the answer to the nearest 0.1 grams per milliliter. So it's telling you right now how to round, because we haven't talked about sig figs yet. You might remember sig figs from physical science. So it's telling you, hey, here's for right now, just round. We'll talk about them later. All right, so if you talk about mass, what goes in the top? Which part? Chris?
The 2,790 grams.
Good job. How did you know that was the grams part?
Because the thing for mass is grams.
Yeah, so it even tells you it has a mass, but even if it doesn't tell you, if it just says it has 2,790 grams, grams always goes with mass, or kilograms always goes with mass. So just make sure that you know, okay, these are the units that go with it. Alright, so the bottom one has milliliters, so 205 milliliters. So it's 2,790 divided by 205, and then you get what, Chris?
0.1. Not 0.1 grams.
Okay, that sounds like you probably didn't write it all the way fully, or you tried to convert it into liters. So just type in 2,790 divided by 205 and see what you get. You're actually pretty close. Alright, what do you have?
13.61.
Good job. So 13.61. Now keep in mind, if you're rounding it into the nearest 0.1, what does this round to?
13.6.
Yep, 13.6. 13.6. And then it tells you what units used for it. You always want to have your units with it. And so it tells you, for this one, if you're still practicing, it will be grams per milliliter. So this would be your final answer for it. So 13.6 grams per milliliter. So that's the answer for it. Alright, anyone have any questions about how to solve this? We're going to get more
Did
practice
you expect
later
us
on.
to get that right? Or did anyone get that right since we didn't do it yesterday?
Yeah, because you can read. And this is not a super hard problem.
I should have got it right.
It's okay. It's fine. It's one of those, if you figured it out and if you used your head and figured out, oh, I can do this, then yeah, it's okay. Chemistry is a thinking class. That's something to where for your homework, we'll start asking questions to try to get you to think early and try to help you figure out problems for it. So try to think. Now don't spend like hours on it thinking, okay? Now if you can't figure it out, you can come ask me in study hall, because next week I'm going to start having you for study hall if you're in 7th grade, 7th hour study hall. So I'll be here. So if you get really stuck and you just think, Ms. Lewis, help me, I don't know what I'm doing, then that's okay. But there's nothing wrong with trying to figure out on your own. But you should always try. Don't just think, I don't know. Oh well. No, always try. It's kind of weird, Ethan, how you almost guessed it right. Just by
Well,
luck.
I did it.
You guessed 13.
So, wait, what is the, what class is 7 hour for you?
Study hall.
Just study hall?
Yeah, I just have y'all basically. So the 10th through 12th grade.
And yeah, what I did on the first one, I think I just overqualified or something.
Yeah, it's okay.
I always do the same things.
It's okay. It's one of those, just looking to see, okay, what is it asking? It wants me to find density. Okay, that's what I'm doing.
I looked up in my notes and I figured out, I was like, well, I think if we divide, and I did a lot of stuff up here, and I was like, oh no.
It's okay.
13 was the closest I got to it.
Yeah, well, I mean, you were actually pretty close. You just didn't round all the way like I wanted to for it.
Guessed it right.
Kinda.
If you actually guessed it right, I would have walked out the room.
Alright, so let's review really quick, because like I told you yesterday, you need to know stuff for
We're
today.
doing a review game or just review?
We'll do a review game now. Because there's only 2 of you, the review games are going to be a little bit different because it's
Rock, paper,
literally
scissors.
either or. How it feels some days. Alright, so we're going to do the Palm game if you remember from last year, just as like a starting one. And I have a lot to do, and I have math. I don't know how long math is going to take. So go ahead and take out a piece of paper so that you can write down stuff you don't know or remember from last year. Since we do have terms, we do have definitions, we're going to do some math today, but you do have some of them that you need to just memorize. So this one basically is going to be a race between you and Ethan, because obviously Jamie and Quentin aren't present in the room. Alright, what's your question?
Me and Ethan are good at math, so it shouldn't take too long.
Hopefully, but we'll do some practice to make sure that you're ready and that you're confident. This math isn't super hard, but it might have been a while since you remember how do I do order of operations again? How do I type it in? So, but yeah, most of them you're probably like, yeah, I got this. I'm fine. We'll be done really quick. Alright, so thinking back over it, what is the branch of science that deals with the study of composition, structure, and properties of matter, the changes that matter undergoes? Go. It was Chris Fairley.
Bruh.
Chemistry.
Chemistry. Alright, what branch of chemistry, be sure to keep track of your points. What is the branch of chemistry that studies carbon specifically? Go. That was Ethan.
Organic.
Organic. What is the
Remember our
one?
points.
Yep, be sure to keep track of it. Your own points for it. Which one is it study basically everything besides chemistry? Sorry, besides carbon. Go. It was Chris Burrell.
Organic.
What was it?
Inorganic.
Inorganic. I thought you said non-organic for a second. Inorganic. Alright, what do you call the type of chemistry whenever you are identifying what substances are present? So you're analyzing. Go. That was Chris.
Bruh.
And chemistry. Or no, not chemistry. Analytic chemistry.
Analytical chemistry, but I'll take it. Alright, what is the chemistry of living things? Go. That was Ethan.
Biochemistry.
Biochemistry. And what's the chemistry which deals with applying theories of physics to the study of reactions and properties of matter? Go.
Physical chemistry.
Physical chemistry. Alright. What is a tentative explanation of a natural phenomenon? Go.
What does it start with?
There's 2 of you.
Okay, is it hypothesis?
Yep, hypothesis. Alright, what is a hypothesis that's passed many experiments now? Go. Okay, that was Ethan.
Theory.
Theory.
You
And
did
what
that
it has
theory.
passed, what if it's passed the test of time? Now what's it called?
Years ago.
Go. I think it was Chris.
I saw this in first.
You wanna give it to him?
Yeah, mine is go.
Law.
Okay. Law, scientific law. Alright, what is, so thinking about the 3 major steps of the scientific method, what's the first major step? So it starts combining the 6 smaller steps together. So what do you call that first major step? Go. That would be
Observing.
observing. What is the second major step? Go. That was Chris.
Hypothesis.
And then what's the last major step? Go. It was Chris again.
Theorizing. No, not theorizing. Experimenting.
Experimenting. Good job. What is the language of science? Go.
Oh.
That was Ethan.
Mathematics.
Mathematics. Let's see. Okay, thinking about if you're trying to hit the bullseye, what means hitting the mark over and over and over again? You might be wrong, but you're hitting the mark over and over and over again. What term applies to that? To hitting the same spot. Go. I think you're trying to get up and down too fast, but you just need to get up. Okay. Precision. And what has to do with trying to actually hit the mark, hit the bullseye? Go. That's Ethan.
Accuracy.
Accuracy. Alright, there are 2 types of exact numbers. Name one. Go.
Counting.
Counting. And what's the other one?
Yes.
Go.
I didn't hear you.
Alright, but you still got it because Ethan didn't move.
Okay. Define.
Define. So, like, there's 100 centimeters in a meter because that is the definition. Alright, there are 3 different types of system of measurement. So, measurement, like
3?
systems. Yeah. Well, what's the one that's just for United States? So, we just traditionally have this one. So, you can give the abbreviation for it, that's fine. Go. That was Ethan though.
FPS.
Hey, say it one more time.
FPS is.
Yep, so the
First
foot
person
pound
should be-
second one. So, foot pound second, but FPS, that works. What's the one that everybody else uses besides us, and we kind of half use it as well? Go. Okay, that was Chris. Metric. And then what's the more exact one for science specifically? Go. JavaScript.
Kelvin?
Not Kelvin, because that's a temperature
What does it
scale.
start with?
In English, you would say it starts with an S.
Yes. Is it abbreviated?
Yep.
Is that the part of the abbreviation?
Yep.
I have no idea.
Alright, Ethan, you know? Alright, the SI system.
Oh,
In
yeah.
French is the Système International des Units, or the International System of Units. We just say the SI system, so it's convenient for us. Alright, so let's go over these prefixes. Alright, what is, alright, what means 1 billionth? 1 billionth. There's a billion of these, like in a meter. Go.
Yeah.
Nano. What's the symbol for nano?
It's the,
Wait. Oh, yeah, no, you can just finish, that's fine.
it's the N.
It's just an N. Alright, what means 1 millionth? Go. I think Ethan barely.
Really?
Millie?
Kilo?
Nope. Alright, Chris?
Is it centi?
Nope. 1 millionth.
What's the number?
M.
Is it milli?
Nope. Micro. Speaking
Micro.
of micro. This one has the weird upside down H. I did look it up. Mu is how you just call that letter.
What is it?
Mu.
Like
Like,
the Pokemon? M-E-W?
YouTube?
yeah. Okay, it's spelled M-U. Well, no, like that's how you pronounce it, but it's the 13th letter of the Greek alphabet. So mu.
Mew's real. That's crazy.
Alright, so 1 millionth, micro. Don't forget, micro, 1 millionth. Alright, what means 1,000th? Go. That's Ethan. Thousand.
Did what?
Thousandth. So there's 1,000 of these in 1 meter or liter.
Centi?
Nope.
Milli?
Milli. So
Bro,
milli,
what a guess.
and it has the prefix M. So don't
See,
forget.
it's narrowing it
M.
down, bro.
Alright, which one means 100th? So there's 100 of these in a meter stick or in a liter. Go. He was Ethan again, really.
Centi.
Cindy, and what's the symbol for it?
Can I get a point for this so I know it?
No.
Don't hold it in your hand, though.
I don't know.
C.
C.
C. Alright, C. So it's made of
C.
centi, C. Alright, so what means 1,000 of a substance? So, like, if you have 1,000 meters, what prefix means 1,000? Go. That's Chris.
Kilo.
Kilo, what's the symbol for it?
K.
Okay, and then what means 1 million of a substance? So if you were to have 1,000,000 meters, what's the prefix? Go. Chris again.
Mega.
Mega, do you know what the symbol is for that one?
N.
Yep, capital M specifically. So lowercase m, milli, capital M, mega. Alright, what is the main unit for length? Go.
Isn't it meter?
Meter? What's the major unit for volume? Go. Alright, Chris again.
Liter?
Liter, and then what's the major unit for mass? I'll take either of the 2 answers. Either one's fine. Go. That's right. And that was not Chris. Ethan.
Gram.
What was it?
Meter. You had it
No,
right.
it's fine, gram. I just thought you said kilogram for a
Oh,
second.
gram.
So gram
Gram.
or kilogram.
I
Either
like
one
that.
works for it. Alright. Anyone have any questions about the table?
Who won?
I think you did. Alright.
17.
Ethan did 117.
No, but I have no lucky number.
How many do you have?
11.
Alright. Alright, go ahead and take out one piece of paper, a pen and a pencil, not the piece of paper that has the answers on it. Put that one away.
Only one piece of paper? I don't have any cover sheet. You need cover sheet. And he's over there. I can't see. You can't read it.
Yeah, I can't.
For today,
And I'm blind. I can't. There's no way I can see it.
I'll let it go. You can. Alright. Quentin and Jamie, you should go ahead and pause the video and go get your proctor so that way you can go get the pen and quiz for you. Don't watch the rest of the video until you have the quiz because we're going to go over some of the questions because some of them are worded a little bit confusing. So don't watch the rest of the chemistry until you're able to take the quiz. And then also please send me the quiz as soon as possible. Alright, so you should have a pen, pencil, and then your cover sheet typically, there's just 2 of you. Once you get your quiz, you may again, you should clear your desk with pen. Remember, you take remember we're taking the quiz in pen, and then we would typically grade in pencil, because of Corona it's a little bit different right now, but you're going to take,
That means there's nothing. I'm used to it too.
that's fine.
What do we need? Cover sheet.
For a cover sheet typically, but since there's only 2 of you, we already talked about it. Alright, everyone everyone take your eyeballs to number 5 really quick. What it's asking for that one is really weird. All it's saying is explain for that one, a millimeter is what fraction of a meter. What it's asking you is trying to say how many or what fraction of it. So if you were to write it out, if you were to have 1 meter, what fraction is a millimeter of it? So how many pieces do you divide up your meter into is what it's asking for. It's just asking it in a really weird way. You can put it like this as a fraction, to where if you have 1 meter, how many millimeters are you going to get? Or you can write it out as the exponent sign. Either way works for it, but that's just what it's asking. And then number 9, to explain that one as well, the SI unit hertz is symbolized Hz. Write the symbol for a unit equal to 10 to the positive 6. So you might want to write that out to see how large that is, and then write what symbol represents 10 to the positive 6, or what symbol for it. You don't have to really write it out with the hertz, but just want to know what symbol means that amount, or 10 raised to the 6th power. And the last one, number 10, this one's weird, but I'll explain this one to you. The SI unit is symbolized cat. Write the symbol for a unit equal to 10,000 mus cat. So it's trying to make you convert for it. So do your best for it, and then we'll talk about it in a minute for it. But it's saying if you have 10,000 the mus of this substance, what symbol is equal to 10,000 of this particular mu? So again, it's kind of weird how they're asking it. Do your best, but then we're going to talk about what we're going to do as well for it. So do your best to try to figure it out. Yes.
If we get 10 right, or if we get 10 wrong, are you going to count it off?
Don't worry about it.
Or if we get it right, will we get is there a bonus?
Maybe.
I guess there's a bonus question.
Maybe. looks like both of you are pretty much done with it. So, as you can probably tell, because I don't like how 9 and 10 are worded, and this is day 3, and even though the curriculum calls for this hard of a quiz on day 3, because I'm a nice person. Bonus number 1. Name one of the 2 types of exact numbers. Remember, there's 2 different types of exact numbers. Write down one. I don't care which one. If you want to write both, that's fine too, but write down one of the exact numbers. Bonus number 2, because I'm extra nice and I still hate number 10. What is the chemistry of, what branch of chemistry is the study of living things? So what branch of chemistry is the study of living things? So you get 2 bonuses. So at the bottom of the page, you can write B1 or bonus 1, write your answer, write B2 or bonus 2. Because I think 9 and 10 are a little bit too intense for day 3 of the year, and that's some intense problem solving right there. So because of that, do try to solve them, but I give you 2 bonuses to basically counteract them in case you didn't get it. But you should still try. Okay.
So if we get 9 or 10 right, is it extra points?
No, you can only get max out of 100. You can't go negative.
Well, no, I know. Like, say we got 1 wrong, we're at a 90. If we get 9 or 10 right, will that be put us up to 100?
Mm-hmm.
So there's technically 4 bonuses then.
No, like 9 and 10 count, and then there's basically you can get 20 extra points. So if we work, what?
I don't get what it means on number 5.
Number 5 is asking you as a fraction to write. Okay, think of it this way: how many millimeters are in a meter? And then write it as a fraction. So 1 over however many millimeters are in here. Oh, I'm sorry.
Does it have to be written as a fraction?
Yes. Because if you just write the whole number, you're saying that there is that many millimeters in a meter. And without giving it away, I can't explain it any better than that, but that's a different number. So write it as a fraction or write it as a negative exponent. Either way works.
Are we grading on our own test?
Mm-hmm.
Or so we're going to give it to you?
Yeah, because it's video. Alright, anybody need more time?
I think we're done graded by
Yeah, I'll probably be done with it today. Ethan, do you need more time or are you done?
I do.
Okay. Maybe about 1 more minute, Ethan, because we gotta go. Try to figure out or just guess.
Right, can you tell me back tonight or just say yes or no? And then we just want to know.
Ask me, I should have, I'm graded by history.
I'm still trying to get some schedule.
Alright, so, once I'm gonna come around and collect them. We can't grade them in class right now because Corona. So, again, Quentin and Jamie, please get them to me as soon as possible. Alright, go and take your textbooks to number page 8, talking about density. We talked about mass versus weight yesterday as well. What is mass, first off? Chris?
Mass is anything that you can see or anything you can sense.
Okay, that's matter specifically. So what is mass?
Anything that has a weight, right?
Close but not quite. Ethan, do you remember from mass from yesterday?
No.
Alright, mass. Maybe not of it. What?
Quantity of matter?
Yeah, so the amount of matter in an object. So whenever you eat food, your mass goes up slightly because you have more matter on the inside. Remember, weight is what, Chris?
weight is, what are you asking?
Like, what is weight defined as? So, like, if you go to the moon, your weight changes, but it's not that your mass has changed, you're still you. But why does your weight change on the moon? Why does it get lighter?
Because the gravitational pull.
Good job. So weight is the gravitational pull pulling down on an object. So we use mass, matter, and weight kind of all loosely, interchangeably in day-to-day speech. Just make note though, for science, matter makes up the physical world. Mass is how much of a matter is in an object, or the quantity of matter in an object. Weight is the force of gravity on an object. I know it feels nitpicky, but just be careful because your book does not necessarily using those terms correctly, and what it's asking for is if you're trying to solve it like in a word problem, is you have to pay attention to what exactly is it asking. Alright, so density. What is density, Ethan? Do you remember from yesterday?
That's how thick something is or whatever.
Okay, not quite. I know where you're coming from, but not quite. Chris?
Compactness.
There you go.
The
So yeah,
volume.
so how tightly packed together. So if you're packing a suitcase, how much stuff you shove into it?
Technically volume, is that another kind of word for it?
Volume, remember, do you remember what volume is?
Yeah, it's like, I know what the conversion thing is, but what do you,
Volume is how
volume
much.
is everything that's in there.
Okay, volume is how much space an object takes up. So right now, does this have a whole lot of volume? Does it take up a lot of space?
No.
Does it have a lot of stuff on the inside though?
No. Yes, it does.
Yes. So does it have high volume or high density?
High density.
High density. Alright, is it taking up more space or less space now, like the edges? More space. So is there more stuff on the inside though?
No.
No. Okay, now, you're right that the same amount of matter is there, but it's more spread out now. So, does it have high density or high volume now?
Both.
It's dense, it's very compact on the inside?
No, it's volume.
Yeah, so it has high volume. So, sometimes volume and density are opposites of each other. Like of this, these are opposites. You can have high density, but low volume. High volume, but low density. Now the amount of matter, the mass stays the same. I'm not taking bits and pieces of the ball off. So matter stays the same. Gravity and weight, I just crushed my fingers. Weight also stays the same for it because gravity is still pulling down on it. Doesn't matter if I hold it open like this, if I close it like this, the weight pulling on it, or gravity pulling on it, its weight isn't changing. So I use this to help show density and volume. Does that help you out now? Alright.
Oh wait, technically when you're lifting weights, you're fighting gravity?
That's one reason why your arms start to burn after a few minutes, or your legs, or whatever it is you're using for it, because you're trying to move the weight against gravity. That's something typically you move it up, or if you're at a special like gym and you're pushing it against a force, like the high intense like training devices, they typically use forces to push it against you besides just gravity. But yeah, that's the reason why those machines work out different types of muscles depending on what you're doing. Alright. So, density, do you make a note that it's the row, or it looks like the P basically for us? Just to know technically it's the row. This measures the compactness of matter. Mathematically, density is the ratio of substance's mass over its volume. Alright, your book points out that the densest naturally occurring element is osmium. So just make a note for it. And your book points out in some cases we use grams over liters, because remember, grams is for mass. So I'm going to write grams up here. And we use liters for volume. Sometimes, depending on what you're using, we'll use centimeters cubed. That's another unit for volume. So liters is the main one, but sometimes you'll see centimeter cubes for small substances. So just make a note for that as well. Alright, so let's practice with this. So if you have your calculators, Ethan, does your calculator work yet or not yet?
No, I have this one, but I don't know if it'll work in this one.
Alright, because I have a spare one if you need to borrow mine. Alright. So let's practice with this first one. So for this one, if the mass is 16.08 grams and the volume is 4 centimeters cubed, find density. All right, first off, how do you set this up? What goes in the top, Chris?
16.0.
Yep. So 16.08 grams. What goes in the bottom, Ethan?
4.
Yep. How do you know?
Because the volume.
Okay, yeah, it does seem, but also look at the units. Units will help tell you. All right, so this one's a pretty easy, straightforward one. Anyone think they have the answer already?
4.
Okay, well
Or
it's
4.02.
16.8.
I did that, but I was rounding. It's 4.02 technically.
Oh, I wrote it down on the board.
I figured you wanted me to.
Yeah, right now, just give me just the whole one. What?
4.02.
That's what I PowerPoint with this being. Yep, so 4.02 is the answer for that first one. I'll make it bigger. It's being finicky, it doesn't want me to move it when it's in the PowerPoint. So, 4.02 grams per cubic
Can
centimeter.
I go ahead and try and solve the next two?
Sure, if you want to.
I don't know how to solve
Sure, I don't do that.
If you want to. So for the answer, just copy down the board just in case they can't see it with the PowerPoint. So 4.02 grams per centimeter cubed. So since this is centimeter cubed and this is grams, you want to include your units for it as well.
Second one is
And I have to freeze it so I can move it over.
32.3.
Wait, let's give Ethan a turn. Alright, Ethan.
the second one.
Yep.
I had 2.61.
Okay, not quite for it. Alright, Chris, what'd you get?
32.384.
That's it for it.
Did you do that?
Alright.
Multiplied the 9.2 times the 3.52.
That's my reason why you want to pay attention. So for this one, I told you that the P or rho, because I don't have the rho symbol, is 9.2. Let me scoot over this a little bit. So so for this one, it's 9.2 grams centimeter cubed. That is the density for it because it is the P. And it says the volume is 3.52 centimeters cubed. So 3.52 centimeters cubed.
That's what I was thinking when I did that. But I
And then
didn't
it's
do it.
asking you find M or find the mass. So you're finding M up here. Now keep in mind, you want to be able to have the ability, if you have an equation like this, to find each part of it. Don't just think it's always divide. If it's density, it's always divide. No. Sometimes I may ask you to find density. Sometimes I might ask you to find mass. Sometimes I might ask you to find volume. You're old enough at this point, you've had enough practice with algebra to where you should be able to figure out, okay, how do I move it around? But if you need help, it's okay, and it's okay, I can help you out and refresh it. So if you need to get M by itself, Ethan, what do? Do you remember from algebra?
Multiply that by 9.2.
So 3.52, you
Yeah,
cancel
32
out,
point.
yeah, you multiply. So you're taking 9.2 times 3.52 centimeters cubed, and I'll give you your answer.
32
Which,
points right
yep, so does that help you out now? Alright,
Can I
last
answer the third
one.
one?
What?
Can I answer the third one or already got it?
Alright, so first off, Ethan, how would you set this one up? So what are you starting off with?
12.77
Alright, is that the density, mass, or volume?
density.
Good job. So 12 point, the symbol is funky and I can't see it very well. I'll have to remember that for next time. Alright, and are you finding volume or are you finding mass?
Yes. Volume.
Volume. So the mass goes in the top or in the bottom?
Top.
Top. So 73.41. Thank you. Alright, so how do I get volume by itself? I know this is probably a little bit harder because it's been a while for algebra. I gotta get the volume from underneath the fraction.
Because I would originally put not a 1 under 12.77. Like put a fraction bar. And then I would multiply, cross multiply.
Extremes by means.
Hey, you gotta get volume out from underneath this though, because right now it's 1 over V, so you have to get it flipped the other way with the reciprocal. So how do you get volume out of the bottom? What's the opposite of divide?
Multiply.
Multiply. So I can move volume over here. Now it's still not helpful because I need volume by itself, but I can pull the volume out of the bottom by multiplying. So how do I get volume over here by itself?
Multiply 12.77.
So just multiply these two together? But that's still not volume by itself. Alright, so volume times this, how do I get rid of this now? What's the opposite of multiplication again?
Divide.
Divide. So I stick this one in the bottom.
Oh, yeah.
So you're basically, so you have the right idea, you're just moving pieces around that didn't need to move around. But yeah, this one you can divide. So it's 73.41 divided by 12.77. Alright, Chris, now give me your answer.
5.74862961.
Yep.
So wait.
So
sorry.
5.7486.
What about 5.75?
Say it one time.
Yeah, can I say something?
Sure.
It seems terribly inefficient. Like, so normally after that problem, what you could just do is that if you see V and you're finding V, just go ahead and put the P under the M and just defines it having to do all that.
No, you can, but for some people that haven't had child, like you've been in summer school the whole time. So because of that, it might have been a while since someone's had to think through,
How do I do this? And he said,
so yeah, if you want to do it in your head, that's fine. But I'm just showing him the steps over how to get there. So since you've had practice for a while, okay, yeah, you can do it basically the shortcut method, but I'm showing him this is how you do it, this is why you do it.
are we ever gonna have to do it without the calculator?
No.
Thank God.
I mean, he's had machine asking, so he knows the same things I do. I don't know.
I would find out if it's.
Yeah, but you've had practice recently, more recently than he has.
Yeah,
He's had
I
it all
would.
summer off, and so that's the reason why we're going over it like a refresher course. Say, okay, this is how you solve it, this is what you do, and I don't know, Quentin and Jamie might need it as well, just to help you kind of get started for it. But you've had a lot more recent practice. You gotta be patient. You gotta be patient with people, with your other classmates.
I'm
And
being
just
patient. I was
wait.
just trying to help him.
Okay, but just make sure in your comments, sometimes it sounds a little bit condescending, so just be careful that you're helping out people and that you need to have patience with them.
You know
Alright,
what?
anyone have any questions though about the density and how to solve density and any part of density? So, if I were to ask you to find P, could you find it, Ethan? Alright, if I were to ask you to find V, could you find it? If you were to find M, could you find it? Yes or no?
Yep.
Alright, so we're going to move on from that then as well. So remember, density has to do with compactness of a substance.
We're doing calculator?
Nope, not yet. Alright, temperature scales! Temperature scales! Now, which is the main one we use in the United States? We talked about this yesterday. Ethan, what?
Yeah.
Okay, that's a system of measurement. What temperature scale do we use?
Oh, Fahrenheit.
Fahrenheit! Alright, what does everybody else typically use? Talked about this yesterday. Chris? Celsius! Now, because scientists want to get super exact, they added a third one. So, we'll come at that one in just a second.
What?
So, you have Fahrenheit and Celsius. You've probably seen this picture, this image before, where you have here's the Fahrenheit scale, here's the Celsius scale, and the scientists, they added the Kelvin scale, because they needed more exact measurements. We're going to talk about that with gases, specifically why there's a reason that they need a more exact one. Now, what is the freezing point of water on the Fahrenheit scale? Ethan, do you remember? For
What?
Fahrenheit?
Oh, Fahrenheit? I
Yeah.
didn't see
For the freezing point of
32.
water?
it.
32 degrees.
I'm sorry,
Alright,
I'm
what
wrong.
is, yes, okay, it's been a while. Alright, what's the freezing point for water on the Celsius scale? Chris? They can't see that.
No,
0. So, 32 degrees Fahrenheit, 0 degrees Celsius, and then we'll talk about Kelvin scale in a minute. So, these two have different kind of starting points, if you think of it that way. Celsius is on purpose, that 0 point is on purpose the starting point for Celsius. Fahrenheit, not really. Now, they on purpose made 100 degrees Celsius as the boiling point for water. I went the wrong direction. Boiling point for water. They said, all right, this will be 100 degrees Celsius. Well, in Fahrenheit, 212 degrees is the boiling point for water. So because of that, which unit is smaller, Fahrenheit or Celsius? Which individual like degree unit?
I think they're the same, aren't they? Which one's smaller? No, Celsius.
Okay, which one, if I'm going up from the freezing point of water up to the boiling point of water, which one has more number of degrees because you have to add up more pieces together? Fahrenheit. So Fahrenheit, the degrees are actually slightly smaller, like on the degree scale, as opposed to the Celsius scale. That's why their conversions are slightly weird and slightly different from it, because one of them, as your book points out the differences between them, that there are 100 degrees difference between the boiling point and freezing point of water. For Fahrenheit, there's 180 degrees difference. And so because of that, that's where you get this fraction of 9 over 5 or 5 over 9, because 100 over 180, that this is 5/9 as a fraction. So that's where these fractions are coming from, and you're flipping them depending on what you're finding. So that's the reasons why from it. There's also the reason why you're adding 32 or subtracting 32, because that's the starting point for Fahrenheit. You do have to memorize these equations. You have to memorize them. They're at the top of page 9 if you needed them. But as a side note, these are the equations. Now keep in mind, just looking at the Celsius one, according to order of operations, what do you do first? So you want to remember from algebra. Alright, Ethan.
You do subtraction first.
Yes, so make sure that for this one, you subtract 32 from the starting point in Fahrenheit, and then multiply it times 5, divide by 9, or divide by 9, multiply times 5. Because remember, order of operations for multiplication and division doesn't matter which one's first. But you do have to do this part first. Now, keep in mind, this is if you're going from Fahrenheit to Celsius. The students last year memorized it as the parentheses kind of look like C, so because of that, the parentheses go with finding the Celsius temperature, so that helps you, great. You already memorized it, also great. For finding Fahrenheit, it's 9/5, no parentheses, plus 32. So what order of operations do you do first for this one, Chris? Yeah, so for this one you do 9 divided by 5 times the Celsius starting point plus 32. So for this one, the addition is last. So you gotta be careful. If you do it out of order, wrong answers. Okay.
So, say with the Celsius one, you'll give us Fahrenheit, right?
Oh yeah, no, I'll give you the starting point for it. So
Okay, yeah, because I thought it's impossible to solve the number.
yeah, no. So I just want to make sure you understand how to do it first. Alright, so let's practice. I think this shows up on the PowerPoint on the screen, and I also want to make sure. So first off, we're just working, we're going from Celsius to Fahrenheit. So how do you go from Celsius to Fahrenheit? What equation am I using if I am finding Fahrenheit? Ethan, which one?
First one.
Which one?
The first one.
If I'm finding Fahrenheit,
You said Celsius or Fahrenheit?
I'm going from Celsius to Fahrenheit. So what am I
you
finding?
added one.
Yeah, so make sure that you start with, okay, what is by itself? So if I'm finding Fahrenheit, I start with this one, the temperature of Fahrenheit. If I'm trying to find Celsius, I want to use the one where it's the temperature of Celsius by itself. So for this first three, I just kept them all basically the same. So you're converting from Celsius to Fahrenheit. Now remember, if you're going from Celsius to Fahrenheit, which one is it? What part do you do first, multiplication or the addition?
You do multiplication, because it's calculators.
Alright, let me get out my answer key.
Can I, use your calculator for
Sure.
this? Because this one is based on calculator.
That's fine.
Have you ever looked into like getting school iPads or anything? Or is that really, no, like for the students, or is that really for the
It's just, your parents are already paying enough money. Alright, so,
Wrong.
alright, what's your first answer, Chris? Just check it.
Oh, I did the first one. I only did the first one.
Okay, what's your first answer?
132 degrees and fourths, so like 132 and that in decimal would be something.
Yeah, so I got 132.8, so just check with your rounding of your calculator. I might have rounded a little bit too
How do
early.
I turn this into decimal again?
Let's see.
From the fraction?
Oh. Ask me to turn it down because I don't want to accidentally mess up your calculator. It's been a long time since I've done
Oh,
that
there's
particular
nothing,
one.
I literally reset it, so there's nothing to mess up.
Second function.
What?
Second function. I can't remember now.
Yeah, I did second function and then the
That's
fraction.
too long.
I said it's been a long time since I've had to do that, so I just haven't. I don't want to guess and I have to do that or whatever. All right, what'd you get, Ethan, for this first one?
The first one?
Yeah.
Oh, I went and did the second one because I thought he had it.
Oh. Okay, you go ahead and start the second one.
Ooh!
I'm gonna pull up, go ahead and move it. But yeah, 32.8 degrees Fahrenheit for that first one. So I think you're all just practice. All right, Ethan, you got the second one?
57 and 5 on it.
All right, why are y'all getting slightly different decimal points where?
57 and 1 of it.
So 9 divided by 5 times 14 plus 32. I still get 57.2. Ask Mr. Nadesky to check your rounding or to check the setting on the rounding. Because
Yeah,
sometimes the
what's your
calculator, wait, because sometimes the calculators, they round too early and that'll mess you up later on. So just be careful. All right.
Yours is right, because if you do 1/5, that is 2.2. So it is 57.2, that's what we have.
Okay, that's what you have?
Yeah,
What did
because
you say?
57 and 1/5, 1/5 is 0.2.
Okay, so just check your calculators to make sure you get the decimal though and not the fraction one. So that'll help you out because we use a lot of decimals in chemistry, so you need to figure out how to
I'll ask
flip them
them.
over.
We have math next.
Yeah, so just make sure because you definitely want the decimal versions because we multiply a lot with decimals in chemistry.
You're not turning to decimals.
Yeah, you could. It's just an extra step.
I knew what to do.
All right, so number 3. Anyone have that one already solved? Yeah, it should be 1.4, but that sounds right. So
That is right,
1.4 degrees Fahrenheit. All right, anyone have any questions about how to solve if you're going from Fahrenheit
What
to
you
Celsius? 1.4 is how it is in decimal. So 1.4 degrees Fahrenheit.
Two bits.
All right, anyone have any questions if you're going from Celsius to Fahrenheit? Alright, let's go the opposite direction now. So Fahrenheit to Celsius. So what equation do you use for finding Celsius? Chris.
The one triple square.
Okay, but which one? Because there's 3 of them.
PC equals 5/9.
Good job. So what's according to order of operation, what do you do first?
Subtract.
Subtract. Just be careful.
155 is 5 minutes.
That sounds right. 155.56 degrees Celsius for that first one. Alright, keep going to the second one.
Negative 27 and 2 ninths.
Oh, not quite.
Negative 43 and 8 ninths.
There you go. Negative 43.
Oh, I did 17
April.
instead of 47.
Oh,
Because it looks like it's 17 minutes.
I don't know. Maybe I'll try to see if I can swap you and Ethan so that way you're closer to the front
I
tomorrow.
should wear my glasses.
That would also be
I
nice.
like it over here.
37 2 ninths.
Good job. So this one I just rounded just to 37.2 degrees Celsius. And then of course for that second one, negative 43.89 or 0.9 if you're rounding up to just one whole digit. Assuming a 10 points instead of digits. Wait. Alright, what's your question?
No, it shouldn't. Never mind. I thought it should be 37.3, but it's not. It's like point. It ends up coming like 0.24 or something. doesn't
Yeah,
it?
so I just rounded them just to the tenths because we haven't talked about sig figs yet. So I just to be consistent, I just rounded to the tenths for all of them. All right, hang on, I still have a minute.
We don't have homework, so it's.
I'm there.
Okay. All right, really quick, the Kelvin scale. So this is the last one. We'll talk about it soon. We'll talk about it on Friday actually more. So the Kelvin scale is very similar. Just wait, very similar to the Celsius scale. The equation for it is on page 9. They needed absolute 0, or the coldest possible temperature. That's why for the Kelvin scale, their starting point is 0 is very, 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 very cold. It's negative 273.15 degrees Celsius, and that's why. Wait, raise your hand. That's why if you're going to go in from Kelvin to Celsius, you subtract or you just add and go back to the opposite. We'll talk more about this on Friday. We're just about out of time. Tomorrow for Jamie and Quentin, we're going to watch the safety lab. So you need to email me and Mission Nadasky to figure out how you can watch the Abeka safety lab videos, because we're going to watch it in class tomorrow, but it doesn't show up on the screen very well. The homework in the video is the same one as it matches in the video as what I will give. So you don't necessarily have to log in tomorrow if you don't want to. So there is no homework tonight because it's Wednesday, but bring your lab books tomorrow, Ethan and Chris. And that's what I said, we'll go over this more on Friday, because we're not going to have time on Thursday. Alright, you can back up.
Wait, I don't even need my assignment book anymore. It's only English or something.
Wait, don't leave, sit down.